One of the most common questions I get: what is Blueprint, how it's helpful, and why we should learn it. Blueprint is Unreal Engine visual scripting system. It allows you to prototype your ideas with connecting nodes together visually. Compared to traditional coding methods when we're learning C++ or C# or any programming language, we used to write lines of code to create our interactive experiences. And with Blueprint, you can achieve the same results by doing that visually. So when you learn Blueprint, you become a developer. By learning Blueprint, you can differentiate yourself from normal visualization artists, and you can create interactive experiences of your projects, where you can explore your projects from the first-person view, third-person view, virtual reality, augmented reality, and much more. You can create tools, you can reuse these tools and these functions across your projects, and it will allow you to have endless possibilities. This is how I describe Blueprint. Blueprint gives us the possibility to create and prototype anything we can think of. One of the main reasons you would learn Blueprint: when you create your architectural project, usually we fly around that project, we take photos and videos. But what if we want to explore the project? What if we want to turn on lights, open doors, change furniture, change materials? We do all that with Blueprint. When you create an Unreal Engine project, and you can see these categories, we have the blank category, we have the ability to create the project based on Blueprint or C++. We're gonna use Blueprint. In addition to this, we have templates that will allow us to jump forward in our creation process. So instead of designing a first-person perspective view from scratch, we have a template for that. Instead of designing a third-person perspective, we have a template for that. Instead of creating a whole system for virtual reality, you are literally one click away from creating a VR project. Same goes for AR, same goes for creating a racing game or the ability to drive cars in your project, and the same goes for the top-down perspective. So if you want a system to view your project from the top, you can start from this template, modify the template to your liking, and keep moving forward. And if you want to explore the other templates, for example, in architecture, we have the collab viewer. This one allows many people, to enter the project, to leave notes, to view from different angles, to measure parts of the project, and so on. We also have a design configurator. This is another nice template. And we have more templates here, like a product configurator, another collab viewer, and we also have the simulation templates here. To get started, let's go back to our project. Here we have the default map when you create any new project. I'll press Ctrl space and open my project map so we can get started. So here we have our project so far, and if you click on play, nothing is going to happen. Our map is gonna load and we have the ability to fly. And that's it. If you press shift, nothing speeds up. If you scroll with the mouse, nothing zooms. And that's what we have. What if you want to explore your project from the first-person view where we cannot fly? Or what if you want to add a third-person character to your project? Let's press escape and let's press Ctrl space. And if we click on the add button here, then go to add feature or content pack. This will open the default templates for us. We have the first person, the third person, the VR, vehicle, and these two. We also have the ability to add C++ templates, and if you click on content, here you can add your templates and add them in future. For now, let's go to Blueprint and let's add the first person template. Let's click on add to project, give it a few seconds, and it will add some folders for us. And these folders contains assets. We have something called PP. It stands for Blueprint. First person character, we have first person game mode, we have a controller, and we have two actors, a projectile and a rifle, as well as weapon component. You definitely don't need these for your architectural project, but that's fine. We can have some fun. Now, In order to add this template to our project, if you click on play, nothing is going to happen. So we need to set the game mode. This is a template ready for us. All we need to do is to go to world settings and set the game mode from here to the first person game mode that we just added. So a game mode will contain information about the character, the HUD, heads up display, the pawn class, the controller. We will discuss these as we go. So if we click here and drag it here, we can add it. Or if you click on this drop down menu and click on BP first person game mode, this will add this game mode to our project. Now, if we press on play, you're gonna see that we're gonna fall to the floor. Let me remove this from the view and click on play again. So now if we walk around, we can jump. So I'm pressing space and you can see the hands on the sides, and you can view now the project from the first person view, which is nice. What if you don't see the world settings? Because by default you won't have this. All you need to do is to go to settings and click on world settings, and this will add this panel for us. And from here we can change the world settings of our project. Let's say you want to add the third person character to your project. All we need to do is to go here again, click on add feature or content pack, add the third person, add to the project, and it will locate this for us. And as you can see, we have the character and we have the third person game mode. So here, all we need to do is to add the third person game mode. Now, if we click on play, we have the third person character, and you can also jump, walk around, move your camera around the character, and anything that you would expect from this template. And these are really, really good starting points for your project if you want to have a system that you can build on top of. Let's say you want to start your project at a specific point every time you click on play. So now when I click play from this camera view, it will start from here. And when I click on play from here, we're gonna fall and then we're gonna start from here. What you need to add is a player start location. And you can do that by going here and let's search for player. And we have a basic actor called player start. Click, drag to your project, move it up so it won't intersect with some other actors. So if you intersect it like so, we're gonna get an error message. So let's move it up. And now, wherever I am, when I press on play, it will start from the position we set on our level or map. Now, if you have this, but you are developing your project and you want to start from this location, let's click here. And from here, you can set the spawn player at, change it from the default player start to the current camera location. Click, and now if you click on play, it will always start from your current camera location, which is very nice. Click space to jump because it's very nice. Let's take a deeper look into what we've added, whether the first person or the third person blueprints, to get slightly better understanding of blueprint. So if we search for the third person from here, we can see it added multiple folders for us. We have blueprint, input, and maps. Maps, this is the default third person map. If you want to develop your character in a special map to work on running mechanics or other mechanics, you can do that on a development map. But for us, we need to go back to our level. So let's take a look, click on play. And here we have even physics. So you have these objects that you can also expand later or explore to have fun, more fun. To explain things on our project, let's open our map again and let's click on the world setting. Right now, we have the third person character, so we can at any time switch this to the first person character. And now if I press on play, so far, so good. Now, let's talk a little bit about the inside of Blueprint. If you click on the button here, list of world blueprints available to the user for editing or creation. That's a long name, I know. Click, you can create a new blueprint class from here, or you can open a blueprint class within the project. You can open the level blueprint, and you can also view if there are any blueprints within our sub-levels, because here I have a couple of sub-levels. So let's click here. We also have the ability to view the project settings. So if we go to Edit, Project Settings, and we go to Maps and Modes, here I have my own blueprint that I made in the past, where I can switch between the first person, the third person, the drone view, and so on. So we can view these from here as well. And we can see the world override. Right now we have the first person blueprint. We can edit that blueprint or create new ones and so on. To explain the term blueprint classes, when it comes to creating blueprints, there are many types that we can create. And when you create a blueprint, you can create blueprints from that blueprint, and they are all named classes. And when it comes to the types of blueprint classes we have the actor blueprints, and these are the most common blueprints we create. So when you want to create the functionality to change an object, or you want to create a light, or you want to create in a video game collectibles or enemies or anything, you create a blueprint actor, and that actor will be empty. You can add anything to that actor, add the functionality, and reuse that actor across your projects. We also have pawn blueprints, and these are type of blueprints that we can possess. So anything that can be controlled by a player or by AI, it's a pawn blueprint. This can be a car or a third-person character, first-person character, and so on. We also have character blueprints, and they are based on the character class, and we have many more types. We have the game mode blueprint, we have the user interface blueprints, and we have custom blueprints. This will make sense once we start creating our blueprints. Now, before we create any blueprint, let's quickly take a look at the blueprint we've added, the first-person character. So let's open the first-person character to understand a little bit more about the blueprint editor and what we have here. So when you open any blueprint actor, you're going to see the event graph. This is where we create nodes, connect them to create functionality. On the right here, you will see the details of some of the nodes you click on or variables, as well as the class defaults. So here are the details or the defaults for our blueprint. On the left here, we have components. From here, we can add components to our blueprint, and below that we have the My Blueprint panel, where we have graphs. We can create multiple event graphs. We have functions, macros, and variables, as well as event dispatchers. If you click here on construction script, so the main difference between this view and this view, the event graph will run when we run our game, and the construction script will run in the editor mode. With the construction script, we can create tools like roads, rails, and anything that we want to adjust before we press on play. In addition to the event graph and the construction script, we have the viewport, and this is the main view. If you've noticed earlier, when we jump, we saw some hands. So these are the hands we see. We have a camera, and we have this capsule component, the arrow, and all these actors we see here are under the components here. So when you click on add, you can add many more components. You can add static meshes, you can add lights, you can add particle effects. If you have other plugins enabled like Cesium plugin, you will also see Cesium components. For example, Cesium Fly To. This component here would allow us to fly between different locations in the world. And if you scroll down, you will see many more components we add. You can add lights, as I mentioned, movement components, and many more things. Blueprint might be scary at the start, but the more you use it, the more you get familiar with it, the easier it gets. source, trust me bro. So let's say you want to modify this blueprint so when you jump you don't see the hands. All you need to do is to click on the hands and remove them. Now if you click compile and go to the project again, when we jump, we don't see hands anymore. Let's say you want to have a specific light always in front of you when you are moving. All you need to do is to click on add. Let's search for a spotlight. Add that light. It's in front of us now. And let's increase the intensity to something really high. Click compile and click on play. And now we see a light that goes with us. So this is how you create a flashlight, for example. So let's go back to our blueprint and let's click on delete. Every time you make a change to your blueprint, the compile button here will go from green. So I press Ctrl Z. This will make sure our blueprint is good to go, and it says exactly that here, good to go. But if there are any problems or any warnings or anything that we have done on an error, it will give us a warning. So that's why we always compile our blueprint. This basically will check that all our nodes and everything is working as intended. Compile, save. These are our two favorite buttons. Let's delete the spotlight. Let's compile and save, and let's close our blueprint and create another so we can understand how blueprint works. So I press Ctrl space and I will go to where I have my level. I will click on this button, and under my project, it's a common practice to create a new folder and name that folder blueprint. Here, right click and you can create a blueprint by simply going to the create basic asset. The first option we see here, blueprint class. Click and we will see the common types of blueprints, and we will see all classes of blueprint. An actor blueprint is the most common blueprint we create. So if you want to create lights, elevators, anything, you want to go with actor blueprint. Pawn blueprint, as it says here, it's something that can be controlled and receive input from a controller. Character blueprint is a type of a pawn blueprint, and it has the ability to walk around, player controller, and so on. Under all classes, it will expose for you all class blueprints that you can create, and you can create a blueprint, and based on that blueprint you can create another. One of the blueprints we can create is camera shake. So if you search for camera shake, if you want to add shake to your camera while you're walking or for your cinematic camera, you can do that from here. If you want to create a blueprint based on another blueprint like the sun and sky, you can do that from here, search for it and create that. However, for now, to keep things simple, all we need to do is to click on actor. This will create a new blueprint for us, and if you save it, that's a good start. But a good practice is to add BP for blueprint underscore, and let's call this, for example, my first blueprint. Let's open this and let's take a look. Just like when we open the first person character, we see now the exact same editor, the blueprint editor. We have components, we have the My Blueprint panel, where we can add graphs, functions, macros, and variables. We have the viewport, the construction script, and the event graph, the details panel on the right, and our most common buttons on the top. Let's say you want to create a blueprint of a light. For that, we can add a static mesh and a light. So if you click on add, we can search for static meshes. Here, under common, we have a static mesh. Once you create a static mesh or add any of the components here, it will ask you to give it a name. You can keep it, but I don't recommend that. So we can call this, for example, light or anything you want. And when you click on this component here, you will see on the right under details, the same details you would see when you click on any static mesh in our world. So if I click on this wall, for example, and go to the details panel, it will have the location, rotation, and scale. It will ask us to set the static mesh and as well as the materials. And if you go back to the blueprint here, click on that static mesh, we have the same settings. We have transform, static mesh, physics, collision, lighting, and all other settings we are familiar with, and as well as some events or new settings that are specific for blueprint, for example, events. If we go to the viewport, right now we don't have a static mesh set on our blueprint. We can change that from here. So here, if we have a light, you can search for a light. You're gonna see all static meshes that are related for lights. So let's add this light, for example. And if you want to add a light from here, so go to add, and let's say we want to add a point light. It will add the point light as a child to this actor. So when we move this actor, the light will also move with it. You may want this, or maybe you don't. All you need to do if you want to change the arrangement of the actors is by clicking on an actor and dragging that actor to another location. Right now, I will keep this, and let's take a look. We have the default scene root. This is set on the 0, 0. We have the light. It's on top of our default scene root, and this is the scene root, this icon here. So the light here, we should give it a better descriptive name. So we can set SM for static mesh and light. That will work. Let's select the point light and let's move it up a little bit, and let's move it to this point here so we can see its effect. And let's try to reduce the intensity. Let's try unit list to candles if you want, and set it to 1 candle or 2 candles. Click compile, and now this is our blueprint. It does not have any functionality, and that's okay. So now if I press on Control Space, this is our blueprint class we've created. And every time we add this to our project, it will have the light mesh and the point light. And we can also view these from here under the components. So now if I click and drag, it will create another, and so on. This is one way we use blueprints to create what we call prefabs. Instead of adding a light, normal static mesh, and then go to the create menu here and find a point light and locate that point light where it should be, and then copy this light multiple times so we can distribute it on our meshes. Imagine if you have a building with many floors, or if you have many spotlights within your project. It will take you so long to add the meshes, add the other components to these meshes, in this case the lights, and so on. So what you can do to keep your project organized is to create a blueprint actor, and open that blueprint actor and add the components you want, and then you can now use this in this project in all its levels and across all other projects. Let's say we want to extend on the functionality of our light or our prefab here. Let's start by cleaning up our scene so we can keep things nice and clean. So I will delete this light as well, and I will move this here. And I will open the blueprint. You can do that by pressing Ctrl B to locate the actor within your content browser, or when you have a specific actor selected, you can press Ctrl E, and that will open the blueprint editor for you, or the type of static mesh or the actor you have selected. So if it's a static mesh, press Ctrl E, it will open the static mesh editor. If you have a blueprint, press Ctrl E, and it will open the blueprint editor. To add functionality to this blueprint, let's imagine we want for this blueprint or this light to be off, and when we get near it, we want it to turn on. We go to the event graph. And before we do that, actually, let's just select the light and set the intensity to 0. And now let's go to the event graph. When you create any blueprint, you're going to see these 3 red nodes. One that says event begin play, the other says event actor begin overlap, and the third event tick. The event begin play will kick off or will fire up when the game starts. Event begin overlap, it will kick off when we overlap with a specific actor. And the third event tick will call in every frame during the game. We will talk about this as we go. For now, let's just delete these 2 and let's talk about event begin play. Let's say the first thing we want to test is for the blueprint here to print to our world, hello world, or whatever sentence we want to print. To do that, let's click and drag from here the executable pin. So many of the nodes will have inputs and outputs depending on their functionality, and you will see different colors, and the colors will indicate what type of node this is, and they will also have an icon. Just like the material editor, if you right click you can move around, if you scroll up and down you can zoom in and out, and if you want to zoom even more, hold Ctrl and zoom even more. Now we can clearly see the icon. From the executable pin here, click and drag, and that will place a new node. This is one way where you can place nodes, or you can right click and search for the node you want to place. The first node we will learn is called print string. And this is good for testing our blueprints and debugging if we have multiple executable pins, if we have multiple nodes or many functionalities and we want to check what's happening, we can print special messages here. For now, all we need to do is to print hello world or hey, what's up? Click and drag, connect this to this, and now if you compile and if you save and if we go to our level, since we have this blueprint here, if you press on play, look at the corner, it printed that message for us. And that's it. Let's go back to the blueprint, and under some nodes, you're going to find this arrow, and from here we can see more inputs. And these inputs here are all variables, the same we see here. So when we say variables, variables are nodes that contain data, and there are many types. We have a string, it's called in pink. We have boolean, it's true or false. We have this variable, it's called text color. It's called linear color structure. We have this variable in green, it's called float. And we have this variable that says key, it's a name, and every variable have its own unique color. The float here is a simple number, decimal number. It cannot be letters. If you do this, it will set it back to a number. A string is basically any text we can type, and the boolean is only on or off, true or false. And the linear color structure variable here, it will define a color structure, and so on. So when we printed the text, it was in this color. If you want to change it to another, you can do that from here. If you want to print the text on the screen, you can do that. So we set it to true. So if you set this to false, these two print to log and print to screen, and compile, and let's click on play. We don't see the text even though it's connected. You can change variables based on events and logic. Sometimes you want for an action to execute only if it's true or false. So we can talk about the flow logic as we go. Right now we enable these, and let's remove this, keep it like so. The duration, we saw the text appearing for 2 seconds and it's gone. You can extend this to 5 seconds or 10 seconds, whatever you want. And let's say you want to store this variable into a variable that we can see from here under variables. You can click and drag, and you can promote this to a variable, and it will prompt us to give this variable a name. So right now we can keep it at duration. And if you want to adjust the value here, so as you can see here now, the number is gone. You can have variables and connect these variables, so you don't need to set things manually. As I said, variables can store data, change data based on the operations we perform. In order to see the value of any variable we add, we need to compile. So here it says, please compile the blueprint. And if we compile the blueprint, we're going to see the value 5 stored in this variable. Now, if I disconnect this, this will go back to its default value. If I want for this to be 5 seconds, all I need to do is to click and drag, and it will override this variable here, or the value within the value we have in our variables. So now if I compile and I click on play, this will stay now for 5 seconds and it's gone. So let's keep moving forward. If you click on the button here, it will add variable for us, and it says new var, new variable, and the default value usually is boolean or any last variable you set. And if you want to change the type of variable, you can click here and you can see the most common variables. So boolean, byte, integer, float, name, string, and so on. We will talk about them as we go, depending on what we will create. The main difference, for example, between integer and a float, as we said here, the float is a decimal number, but an integer is a true number. So click and drag. Let's set it to get or set. It doesn't really matter as of now because we want to see the value here. Compile, and here you can see the number 0. If you try to override this with 5.5, it will reset this to 5. If you try to type 6, no problem. If you try to type any number with any decimal, and this can be good, for example, for the number of the floor. Duration, here we see the decimal, so it's 5.0, and you can set this to any value you want. We will understand these better and their functions as we develop more blueprints. For now, let's remove what we have and let's also delete these, and let's talk about turning our light when we get near it. In order to define how near we want to get to our light, we need to add a collision volume. And we can do that from here, from the add new component, and you can search for collision. We have box collision, capsule collision, sphere collision, you can choose from. I will select on box collision, and this will add a volume of a box around our mesh. And if you go back here, press on G, you are also going to see that box. If you want to make this box bigger, you can go back to the blueprint, select the box and move it around your mesh, like so. Press on R to scale or click on here to scale, and you can make it bigger. And this is a scenario where we can use print string to check when the player is overlapping with the box or not, compared to printing string when event begin play. Now we have our collision and we want to do things with it. If you go to the event graph, you can click on the box and we can go to the details panel here. We can see events, and if you have any component selected, Unreal Engine will help us making decisions. So when you right click, because we have the box selected, the first option we see is add event for box, call function on box. And if we change this to a box collision, so it's more clear, right click and you will see add event for box collision, call function on box collision, and then we will see all the other functions and actions we can create. The reason we see these is because we have context sensitive enabled, and that's how Unreal Engine helps us. This is important to keep on, especially if you are a beginner. If you disable this, you're going to see many more actions, and here it says all possible actions, not related to the box. Sometimes you may want to disable this if you want something very specific, but in most scenarios, we keep this enabled and we select the specific components or variables and work with this on, so it will help us take better decisions with less errors. So since I have my box collision selected, I can right click and we want to add an event for our box. We have collision, input, physics, and so on. We want collision. And here we have the base collision events we can add. Add on component begin overlap, add on component end overlap. These are the most common. So if you click here, it will add another red node. And as we discussed, red nodes are here for when we want things to happen, to have some events. Let's click on the box again and let's add event end overlap. So you can do that in multiple ways, and notice how the icon changed from plus to select. I will click on the plus here and that will add the end overlap for us. And if we click on the box again or any node and we are making a spaghetti blueprint, something very big, you can click here and it will locate that for you. Now, this is a good time to print string just for testing purposes. So click and drag and search for print string, and let's say begin overlap. And you can press Ctrl D to duplicate or Ctrl C, Ctrl V if you want to make a copy of your node. Click and drag to connect this here, and let's say end overlap. Compile, and let's test this. Click on play, and let's get near the box. Notice at the corner how it says begin overlap, and if I go outside the volume, end overlap. I will do that again, begin, and so on. So this is a good start. If we look at our components, we said that we want to change the intensity of the light when we get near the box collision. To do that, click on the point light, click and drag, and that will add it to our event graph. And if you click and drag from the point light, you will see less options. And here, these are all the things we can do for the selected point light. And let's say you are not sure what exactly you are looking for to change. That's okay. Click on the point light and let's take a look at the details panel. We want the intensity. So that's a good start. Click and drag and let's search for intensity. As you can see here, under rendering, component, light, we have these settings. Set the IES intensity scale. This is another option here. Set indirect lighting intensity. This is an option here. And we have set intensity. This is what we want. And you will see other options. Sometimes they are similar, but the first options you're gonna see above this line are the most relative options you want to control. So click. It will add another actor for us. That's okay. We can remove it and connect this here. And if you click on the light and take a look at the setting here, it's 0.0. And look here, it's also 0.0. And if you look at the color of the pin, this is a float value. As we discussed, it's a variable. It's a decimal number. So we can set the intensity from here, or we can create a variable, change that variable to float, and let's name this variable by pressing on F2 and let's say light on or light intensity. You can name the variable anything you want as long as it's descriptive. So before we see the value of this variable, we need to compile and we can set this to 3. And we can create another variable. So press on Ctrl D when you have a variable selected and it will duplicate that variable for you. So press F2 to rename this and we can call it light off. Compile and we can set the intensity to 0. This is very useful to create variables when you have many actors and you don't want to set the values manually every time. Of course, we can say when we begin overlap, set it to 5 or 3 or whatever. But if you want something more consistent, you can use variables, store the information or the value within that variable, and add that variable here. So click and drag. You can add it directly here. It will connect it. And click and drag. If you drag this anywhere, you will have two options, get and set. Get is going to get the value of the variable and put it here. Set, you can change the value to any value you want. And that goes for all variables. And that's the beauty of Unreal and Blueprint. Now, let's say when we end overlap, we want to turn off the light. So all we need to do is to click from here, set intensity again, and click and drag. And the new intensity, we can keep it at 0, or we can add our variable like so. So this one have intensity of 0. Now if you compile and if we go to our level, click on play, let's get near the light. It's on, and when we leave, it's off. On, off. And if you want to see this firing in real time, so we can understand our logic or what's happening better, you can put this here on the side. So let's make it slightly bigger and zoom out. And let's say I want to put it here. And now if I press on play, when I get near, you can see how it's firing up. And when I get far, you can see how the other value and overlap is firing up. This is extremely helpful for debugging. And if you don't see this firing, that's because we may need to click on the expand toolbar here and click on the option from no debug object selected and select our blueprint. So if you set this to no debug object and click on play, we will not see our blueprint debugging. So click here and set the blueprint that we want to debug, click on play, and now we can see it firing in real time. So we have better understanding of our blueprint and what's happening. In addition to setting the intensity of the light, let's say you also want to set the color of the light. Since when we click on a light, we have all these settings, we have the light color, we can also do that. All we need to do is to click and drag and search for another value we want to change. Let's say it's light color. Click, drag, and set light color. If you click here, it will add a point light, and if you click here, it will simply add just set light color. Do this. And now, if we set the intensity, so in order for this to work, it must go through the execution flow. The light color doesn't really matter when the light is off, so that's fine. Click here and you can set this to any light you like. So let's make it purple and click on compile, save. And now when we press on play, let's put this on the side and let's walk. Now we can see that the light is different, even though the light color here is actually white. Through the event graph, we override the default value of the light to this new light. So let's say you want to create another blueprint of this light like so, and you want for these two to have different light colors. We can do that. So right now, if we get near this, it has this color. If we go out, it has this color. How do we change it? Well, as I mentioned earlier, that's where the construction script comes in handy. Now, if you click on the actor and go to the details panel, we don't see any special details or options. They are the exact options we are used to. Now, if you want to add some details or options that you can change here based on the actor you have selected, we do that from the construction script. So from here, I will click and drag. I will add my point light, and if we want to change the light color, we can do that. So click and drag and let's say set light color. Connect this here. And in order for us to be able to change the light color, we need to promote this to a variable. So click and drag, promote to a variable. And right now it says new light color. That's okay. Click compile. Click save. When you click on compile, you can see that this fired up in the editor without the need to play the level. If you go here and you click on any of these actors, technically nothing changed, and that's because we need to expose the variable to be edited. This is great when you are a programmer and you're working with artists and you want for the artists to control just specific settings, not all the settings. Let's say in this scenario, we only want the artist to change the light color. Here, you can see there is closed eye. Now you know what this is. So if you click here, now it's an eye. It's public variable and it can be edited on each instance of this blueprint. When you make multiple copies of every blueprint, they are each their own instance. Since this is a public value, a public variable that we can edit, if you go back, let's save and click on the light, here we see that we have a new light color. If you don't see it, just make sure you compile your blueprint before you see any changes here. Now we have 3 instances and each instance can have its own unique light color. So let's say this one will be reddish pink. Let's say this one will be blue. And let's say this one will be green. Now, if we press on play and we go near this light or this light or this light, it will still have the same value. That's because in the blueprint logic, we are overriding what we have in the construction script. So let's disable this, hold Alt and click on the pin to cancel the connection. And now if we compile and save and play, this is green, this is blue, and this is pink. Let's say that's cool, but we want also to adjust the value that we have here. Let's say we don't want to do this from the construction script. We want to do it from the event graph. So we compile again and save and play. Now these are back to default, right? 100% right. It will be the same. And that's why we create variables. So now if we click and drag this value here or promote this to a variable, click on compile, and now we have the colors of our lights. They are still the same because they are using the same variable. Click on play. This will be green, this will be blue, and this will be pink. Alright, let's keep learning about blueprint by creating a door. So I will remove these 2 lights to have more space or less distractions, and I will bring my door. I simply added this earlier and Ctrl X to hide it, so we have element of surprise. now. We discussed earlier that you can press on the content drawer or content browser with a right click and create a blueprint class and create an actor. Then once you create your actor, you can add your static meshes like so. Add a static mesh and one static mesh for the door, one for the door frame. There is another method to create blueprint actors. Let's say you already placed some of your actors in the world and you need to convert your static meshes into a blueprint. Select the objects that you want to turn into a blueprint. Then let's go to the button here on the tab and click on Convert Selection to Blueprint Class. Click, you're going to have this menu here, this panel, and it will ask you, do you want child actors or do you want to harvest components or do you want to create from any of these classes? We will keep it on actor and I will click on harvest components and I will name my blueprint to blueprint BP basic door. I will click on select and that will open the same editor for us with our static meshes harvested. And if I want to locate this, I can simply click and drag and add the doors I want to add. Now notice that the pivot is not exactly where we want it to be, and maybe you may want to change this. You can do that from your blueprint. We have the shared route here, and if we search for it, it's here. And we can see that our static meshes are under the floor. You can go to any of the orthographic views and simply locate this where it needs to be. So now it's in the middle. If we go to the tab, it's also in the middle or almost. That's fine. If I compile and save, we're going to see that our other blueprints raised up because they will have these values here. However, if I click and drag, this will be its incorrect location. Now, that's a good start. So we can either remove these, move them down, or keep this. Let's go to our door and let's switch back to the perspective mode. And let's say this time when we are near the door, we want to press a button like E or whatever to open the door. The first thing we need to add is add another collision component. So I will search for box. It will find box collision for me. I will make this box slightly bigger and this will allow me to enable my controls when I am near the object. So let's go to the right view. Set it in the right location. It can be any size we want. Just keep that in mind. And I think this is good enough. Now, let's go to the event graph and let's delete these. And let's click on the door and click and drag and it's here. Now, notice how the name is not really good and it's not really helpful. It's always a good idea to name our components. So this here is the door frame and this here is the door panel. Compile, go to the event graph, and now this is readable. As I said earlier, we want to press a button to open the door. So let's right click somewhere in our blueprint graph and search for that button. Let's say in this case it's E. So let's type E and then you can type keyboard. Now, I don't recommend doing this because there are action inputs that we can use in future lessons where we can have the controls we want. However, for the sake of learning, we will do that from here. So that's okay. And now we can find the E key. If I press on this, we want to control our door. But before we do that, let's simply print a string and let's type E is pressed. And let's test this. Spoiler alert, it will not work, but now I'm pressing E, it's not working, and that's to be expected. You can change this behavior in two ways. One way I don't recommend is for testing purposes, and the other will be enable the inputs with the collision box. Now, the method I don't recommend is by simply clicking on the class defaults and search for enable input. So here we have input, auto receive input, it's disabled. If you set this to player 0, and player 0 is us, the user, and other players are other players. So click on player 0 and now compile and click on play. You can see now when we press E, it's being pressed. That's now expected. For now, I will set this back to disabled. I don't recommend using this because if you have many blueprints, they will override each other and it might create problems. Let's click on the box and name it to box collision. and let's scroll all the way down to where we have events. Click on add begin overlap and click on the box again and click on add end overlap. And as you saw earlier, we had something to do with the input. So click and drag, and if you type enable input, you will see that this is now we have enable input when begin overlap, and from here if you search for disable input, you will also see under input disable input. If you try to compile this and save it, so compiling is now working, but you can see that is not working. We don't have E, even though we are 100% overlapping with the door. The reason is because we need to set the player controller. So click from here and get player controller. This is something you need to memorize. Whenever you are changing inputs and whatnot, you need the player controller. So get player controller. The player index is 0. It's us. So again, if we go to class defaults here under auto receive input, if we set this to player 0, this is player index 0. You can connect these both here. Now if you compile and if you press on play, press E outside of the collision, it's not working. Go near the door, press E, and now we can see it's working, and that's a good start. So when we are talking about opening a door and closing that door, what are we talking about exactly? If you click on this door and if you press on this button or press on E to change the rotation, if you change on the Z axis, you can see that we can open and close the door. So we want to modify the rotation of this static mesh in order to open it or close it. And in order to do that, we have our door panel here and we have our E button here. That's a good start. Click on the node, and from here, if you search for rotation, we will see under transformation, we have many options. We have add local rotation, relative rotation, world rotation, and so on. The best method is to explore and see what they do, or if you hover on top of any of these, you can learn more. For now, we simply want to add local rotation. And when we add this, we can see that, yep, this is looking nice. We have the target, which is the door. We have the rotation. It says here delta rotation, and we have the executable pin. If you click here, you will see some other options. Sometimes I like to explore these. For now, we don't want these. Now, click, connect this here, and let's say we want to change the rotation on what axis? Do you want to change it on the X? Do you want to change it on the Y? Or do you want to change it on the Z? On the Z, that's for sure. So here, if you change this to, let's say, 80 degrees, click compile, and now let's try this. When we get close to the door and press on E, you can see it's being added 80 degrees every single time. And also that's to be expected because of the logic we've created here. Let's say first things first, you don't want the door to snap 80 degrees just like that. And you also want to be able to open and close the door. Let me say that there are so many ways to achieve this. This is one of them. First, let's go back to Blueprint, and we need to get rid of the add, focus on add local rotation. We need to replace it with set local rotation. So add will add rotation every time we click on E. And as we said earlier, when you search here for rotation, we have add local rotation, and we also have set relative rotation. First, let's remove these here and let's go back to the basics. Now, first, let's introduce a timeline. So if you right click and search for timeline, timeline is a special type of node where we can create animations. And let's say this one is door animation, we can call it. And it has these inputs and these outputs: play, play from start, stop, reverse, and so on. And we also have update and finished and direction. Good start. If you open this node, and not all nodes can be opened, so this one here can be opened, double click, it will add a new panel for us. And here we can add tracks. So here we can see add a track. We have multiple types of track. We have a float track, and we have a vector track, and we have event track, we have color track. Float track, we already discussed this. It's a decimal number. A vector track, this will have X, Y, Z. And let me quickly show you. So when we add any variable, we have float, and we have vector. A vector is a point in space. So click on vector, compile. Here we have 3 values. They can be RGB, XYZ, and so on. Float, on the other hand, so if we add float, this one, after we compile, will only have 1 value. So that's the main difference between a float and a vector. If you want to create a vector from floats, you need then to add 3 floats and we can combine them. We will explain this as we go. Let's delete this because we don't need them for now. And let's open our animation here. We want to add a normal float track because we want to control our rotation on one axis only, and that is the z-axis. And we can say this is a new track, we can call it animation or anything you want. In this track here, we can see some information on the left, we have our timeline on the right, we have the time, and we have the values. So 0, 0.5, 1, and so on. We want to set the time. Let's say we want 2 seconds for our door to open and close. So we can set the number here to 2. And now our animation will play within 2 seconds. What animation? We need to add keyframes. So right click and we can create a key to our curve, and another right click and we can create another key. Click on the first key. We want the time to be 0 and for the value to be 0. And for the second key, we want for the time to be on 2 and for the value to be on 1. So our animation will play from value 0 to value 1. We can set this to a value of 80 degrees if you want, but the way I prefer doing things is just go from 0 to 1, and then I can use some math operations to set the exact values I want. I will explain. Let's go to the event graph. And you can see that we have a new output pin appeared, and that will represent what we've created here. We called it animation. It goes from 0 to 1, and it's a float. If you add another vector, you can see XYZ, and it has this value or this color. And when you hover your mouse on top of any of these pins, you can learn what are these. For now, I don't want the vector, so we can right click and delete. Let's go back to the event graph. And when we press, we want to play the animation. Now, what animation do we want to play? We want to play the animation of rotating our door. So we can click from the door panel and drag, and we can search for rotation. As I said, we have add local rotation, relative rotation, word rotation, and they all start with add. Then we have get, and then we have set, relative location and rotation, set relative rotation, and so on. We're gonna use set relative rotation. And now, as earlier, we have the execution pin, we have the target, and we have the new rotation. Now, if you click this here, that's a good start, but how do we set these values? Many of the pins we have, they can be broken. So right now we have just one input for the X, Y, and Z, and you can click on the variable and search for rotator. So this is a 3D rotation. Click and drag, click on get. You can connect these two here. That's perfect. But how do we connect this here? Right now, it's not possible because this has 1 value and this has 3 values. Well, to do that, you can right click and click on split structure pin. And this will turn our rotator value into 3 inputs. So this variable here, if you click on get and right click, you can also split this into 3 values. In terms of 3D rotation, as you can see here, X, Y, and Z, so they are roll, pitch, and yaw. Right now, I don't need this variable, I just created it so to demonstrate better what's happening here. Now, you can connect this here to the Z, and technically our animation will play, but it will only play for the value of 1, because here in our timeline, it goes from value of 0 to value of 1. So let's set this to a value of 100, just for the fun of it. Click compile, and let's click on play. And now if I press on E, you can see for 2 seconds, our animation played from 0 to 100, and that's it. If I press on E again, nothing will happen. What if we want to close the door? Let's talk about that. Let's go back to the event graph, and here, let me introduce you to another node called flip-flop. This will control the logic of our blueprint. So we have something called flow control. We have flip-flop. Just like a light, it's on and off. When you press on the button once, it will execute A. When you press another time, it will execute B, and it goes between these two. So let me demonstrate. Let's print a string for A, let's say, and let's print another string for B, just to see how this goes. Let's click play, and let's go near the door, so the E button would work. A, B, A, B. And if you want to view the logic, what's happening here, let's make this bigger, and here, A, B. Perhaps we need to change the debug, so that's why it didn't work. Now if we change this here to basic door, click on play, and now A, B. Perfect. Now let's delete these two and let's connect A to play and B to reverse the animation, and we can now compile, and let's click on play, and if I go near my door, press on E once, it will open the door, press E again, it will close the door. Let's say we want another way to change the value. I don't want to open this every single time and I change the value from here. Like, let's press F first to focus selection. Let's select this and let's set it to 1, just like that. Let's press F again. And now you would expect that if we press on play, this will open only barely 1. As you can see, on 2 seconds is extremely slow. How do we change this? Well, in Blueprint, we can perform math operations. From here, I will click and drag, and we can perform some math operations. So we can go to where we have operations or operators, utilities, scroll to operators, can see we have these math operations. We have add, divide, equal. So this is good for checking true or false, or if two values are equal to each other, perform the specific operation, greater, less, and so on. We have multiply. Multiply, if you multiply a value of 1 with 0, we're gonna get 0. But if you multiply the value of 1 with 80 or 90, we get the value of 90. For me, I want to multiply this with minus 90, and I will click from this pin to this, and now let's try our animation again. I will go to play, and I will go near my door. I press on E. You can see the door now is moving, opening and closing 90 degrees. Very nice. So this is a good start. There are many things we can learn and do to control the orientation of the door, or for the door to open. If we come from this side, then it would open to the other side, or if we open from this side, it will go to the other. These are some advanced topics I would love to cover in future, and many of them are also covered and uploaded to our academy if you want to learn more. Now, to make it clear, E here is just a placeholder, and you can trigger the animation of the door in any way you like. So now we pressed a button with a flip-flop to control the opening and closing animation, but we can also do that with the collision for the door to open when we get near it and to close when we go far. So let me delete these and show you. I will click and drag this to play, and when we leave the collision box, we want for the animation to reverse. And here, right now, it's set to minus 90. You can promote this to a variable, and let's say door open value, and click on compile. You can expose this to a public parameter that we can adjust. Let's compile again, and let's make another copy of this door. Let's say we want for this door to open to the other side, and for this door to open in the opposite side. Now I click on play, and if I get near, it will open to our side, and if I leave, it will close. And for this door, if I go near it, it will open to this side, and if I leave, it will close. So there are many methods you can trigger events and control how things react in the world, and these two today are one of them. Let's keep going. All right, so I hope now we learned some basics, and Blueprint is not as scary as it used to be. Trust me, it's really easy to learn. The more nodes you use, the more things and exercises you do, the more familiar and more things you can make with it. One important thing I want to highlight, as we said earlier, when you press on play, we can use the first person or the third person character to move inside our project. And now I have no collisions in the project. So let me show you one quick and easy way to create collisions. If you click on the walls or the floors and you want to create collisions on these, I will select, let's say, the floors of this villa. I press Ctrl B, and here I will type floor. Here are the floors of my project, and I can select the important floors or parts of them, so I don't recommend doing this to all your static meshes because collisions can be little expensive. But for now, we will do the expensive way, assuming our project is small. We will type floor here and the walls, and we can right click all these assets, let's say, if you want to add collisions to them or part of them. That's why it's really important to name your meshes. Now, the easiest way to add collisions on our specific meshes here is to select the meshes that we want to add collisions to, and then go to Asset Actions and click on Edit Selection in Property Matrix. This will load our floors, and if you select all these, we can change properties in bulk. You don't need to do this on every single mesh, and that is turning the collision on our meshes. If you go to Static Mesh and go to Body Setup and go to the collision complexity, right now it's using the project default. There is no collision on these meshes, and you can switch this to use complex collision as simple. Now we have this icon. This means this changed. So I click on save, and let's do the same quickly for the walls, or let's test it before we do so. So now I press on play, and now I can walk on my floor. I can go through these, and I can also go through the walls. Some meshes, when you import them, they already have collisions, and they use different types of collisions. The other method you can do, and I recommend, is using box collision. So if you go to the window and go to place actors, under here we have volumes, and we have something called blocking volume. You can place some of these volumes in your level, or let's say if you don't want for the player to go a specific area, or you can place them on the walls or floors if you want to use the blocking volume. This is one method to add collisions as well. However, in the scenario of this lesson, we will use what we used here. So we will find our wall meshes and click on the wall meshes we want to enable the collision on. Right click, Asset Actions, Edit Selection in Property Matrix, select the walls and go again to Static Mesh, Body Setup, Collision Complexity, change this to Use Complex as Simple. Give it a few seconds and click on Save. And the easiest way to visualize collisions is by pressing Alt-C, and you are going to see what objects have collisions and what objects, like this here, does not have collision. So the floor, you can open this individual mesh, and we can also find the exact same setting we changed from here under here. Here, if you search for collision, we're gonna find collision complexity. You can set this to use complex collision as simple, and this will use the geometry of the mesh for us to create a collision. This is expensive, and I don't recommend doing this on all your project. Other methods you can add collision to your mesh, depending on the type of the mesh, is by going to collision here, and you can add types of collision. You have a simple box collision, capsule, sphere, and other types where it's going to try to create a collision around your mesh. This is not 100% accurate, and you may or may not want this, but you can also set these on simple meshes. So I press Ctrl Z, and the option here, use complex collision as simple, it's okay to use it on really simple meshes, but when you have such static meshes like this one, it's not okay to use it on such meshes. On such meshes, all you need to do is to go to collision and add a box collision, like so. It already has a collision, one of these collisions here. So these are depending on the quality. You can read how many sides, for example, there is 10 sides, 18 sides, and so on. If you want to remove the collision, you can do that from here, and you can go back here again, and you can add the collisions from here or from here as well. Auto convex collision. You can set the hole count, max hole vertices, and the hole precision. Click apply, and this will create a collision around your mesh. This is one of the good ways to do so. And now we can see that we have a collision around the mesh. So now if we press on play, we can see that we have collisions on the walls, on the floors, and other areas. So we can do that here I don't have collision on the stairs. It's funny, but by doing this, you can achieve the collision. This is a problem you're going to face if you use complex collision as simple collisions overlapping, and that will depend on how your mesh is made as well. So here, if I zoom out, we can see that this might be affecting our collision based on the height of our mesh. So you need to be careful when you are creating your collisions and test every now and then, walk around the project and so on. One of the reasons I recommend using the blocking volume is because you can see the collisions and move them wherever you like. So keep that in mind. This is one way you can add collisions. Now, before we continue, I want to show you the Cesium pawn, the Cesium game mode, because we are using now Cesium to fill in the world around us. So I press Alt-C to remove the collision view. And now if you press on play, we earlier saw that we can use the first person character and the third person character to fly or to move around our project. But what if we want to fly around Earth? Well, you can do that. Thankfully, Cesium made something for us. When you download the Cesium plugin and press Ctrl space, you can go to the content, engine content. We need to see the plugins. If you don't see these, you need to click on the setting here and click on show engine content and plugin content. Go to plugins and here we can search for Cesium. So let's type Cesium and we can see Cesium related actors. Press on one of these. So these are C++ classes. You will find two folders: Cesium for Unreal Engine content, Cesium for Unreal C++ classes. So we need to go to Cesium for Unreal content, and here you're gonna see we have a dynamic pawn, and you should be familiar with this icon now. This is a game mode. This is the floating game mode. If you click and drag, add this here, it will change these settings for us based on the settings that this has. And now, if you press on play, we can now fly. And not only fly, if you open the blueprint later, you will see different options to increase the camera speed. So now I press hover my mouse. So now I scroll up or down to move fast or slow. The world is loading around us. So let's press escape and go back to where were we? Here, press on play. And now we can fly around the globe. This is very nice. You can also press on T. This is related for the Cesium game mode, and you can also change the time of day. Just like that. Very nice. Now, I also have my own game mode that I am developing. It's called VRD game mode. If you press on play, you will see this character, the first person character, and you can zoom in, you can zoom out. Look at this funny character. Stop jumping, please. Thank you. I press T and I click on TPS. This is for the third person view. I can walk in a third person view. If I press T again, I can go to the first person view and I can now move with the first person view. If I click on world, this is the Cesium pawn, and based on where I place this, I can also fly around. This is still under heavy development. Keep an eye on what we are doing with this channel and with VR Division Academy. I hope you found this lesson useful. Every like you make, every comment you make, they actually support us in making more of these lessons. In the next lesson, we will wrap up our series where we package our project so you can share the project with others. Thank you so much for watching, and I will see you in the next one. Take care.